All right, this is the third problem, and we've been going through Cramer's rule. There's no doubt about it. My work over here is also Cramer's rule. What I want to do is just simply talk about using software to do this. And let me define the variables. There's three variables: x, y, and z. But there's also parameters a, b, c, and d. I'll write this down. So a, b, c, d, and I'll say they're variables. I'm going to do a copy paste. I'm going to copy these things, and I'm going to retype them. A single quote mark. And I'm defining all of those variables at one time. How many variables are there? There's 7, all right? I'm going to say equation 1, which is not a variable. I'm going to use the equal sign, and I'm going to assign it x plus y plus z, a double equal sign indicating it's an equation. Equation 2, EQ2, is going to be assigned a star x plus b star y plus c star z, double equal sign indicating equation, equals d. Equation 3, EQ3, that's a third equation. I'm making these names up, by the way. They make sense to me. Like EQ1, you could call it Bob if you wanted to. I'm just saying it makes most sense to me. EQ3 is the third equation. What's that? A squared times x plus b squared times y plus c squared times z, and that equals d squared. Okay, and now what I'm going to do now is I'm going to solve, S-O-L-V-E, and I have a listing, and the listing I have is equation 1, EQ1, EQ2, EQ3, that's a listing now, and I want to solve for the triplet. What's the triplet going to be? X, Y, Z. X, Y, Z. You might be horribly confused by the output, and that's one of the reasons that sometimes software can be very damaging. You don't know what it's giving you. And looking at it, kind of looking at it, what do I notice? I've got answers, all right? Now, someone says, I don't understand those answers at all as they relate to the answer key. But what I want to do is I want to look at X first. This is X. Now, if I look at X, I'm looking at it, and this is X right over here. I'm going to copy it. And what I want to do is I'm going to paste it in. And what I'd like to do, I'm going to try to factor that. And what do I see? I see B minus D, C minus D, A minus B, A minus C. I'm clearly seeing what they got for X. Now what I want to do is I want to go to Y. Right, I'm going to do another copy paste. This is the Y. I'm going to type that in. And it looks kind of crazy to me, so I'm going to try to factor that too. And I want to see if I got what they got. All right. Again, I might be a little confused by it, but I'm seeing the bottom, A minus B, B minus C. On top, I see A minus D, C minus D. They factor out a -1 over here. And I noticed that over there. So really, I could have written D minus C. So that's the same, absolutely the same. One thing remarkable, though, is how quick Sage can go through solving that system. Whereas when you're doing this, even using Cramer's rule, it's brutal. To me, it's brutal. Those determinants are brutal. I shouldn't say brutal. It takes time and effort. Sage is kind of like fluid. Let's do the last one, which is Z. Let's see how we're doing over here. And this is Z. I'm just going to copy what Z is right over here. And I'm going to paste that in. And I'm going to factor it again so I can, whoops, that's factor, right? And what do we get? Well, let's see if we got the same thing. And again, I'm looking at it. And let's take a look what I got. A minus D, B minus D, A minus C, B minus C. Everything is working as advertised, by the way. So yeah, it's a good check on what I've done over here. Sorry about that. I didn't mean to blow it up so much. It's a good check. All right, so I just use Sage to check this out. How is it being done? It's being done by determinants. You can also use Sage to compute determinants. That's what we've done in the past. All right, thank you so much for paying attention.